Hi guys, this is section 11.1, which is simplifying radicals. There's a few rules you need to know to make sure that what you have, your answer, is in simplest form. Okay, so number one, the radicand, or whatever's under the radical, cannot have any perfect squares other than 1. So no perfect squares in the radical other than 1. So for example, if you have radical 20, that's like saying radical 4 times 5, and radical 4 is a perfect square. So it's radical 20 is not in simplest form. Okay, so you need to break that down as much as possible. Number two is the radicand, or under the radical, cannot have any fractions, so no fractions in the radical. And here's an example. You have 2/3 under the radical. Be careful with your homework. If it's supposed to be radical 2/3, make sure you write it like that. If it's radical 2/3, make sure the whole 2/3 are underneath the radical. So be careful with that, okay? And number three, the third rule, no radical in the denominator. For example, 3 over radical 5. Okay, so that wouldn't work. And in this case, you can see radical 2/3. It is a fraction, but radical 3 is in the denominator as well. So just be careful with all three rules. If you can satisfy all three rules, no perfect squares under radical, no fractions under the radical, and no radicals in the denominator, then your answer is in simplified radical form. Okay, or simplest radical form. Here's some examples on what's going to happen. Removing the perfect square factors. So what we got to do is break it down to factors. 192, if you know that it's 64 times 3, that's great. Because a radical 64 just becomes 8. So your answer becomes 8 radical 3. Yeah, and it's 8 times. Remember, these are times, yeah? So it's 8 times radical 3. If you didn't know and you needed to break it down, you could say 2 times radical, and if you went to that, that would be 96. And then you could break this down again if you're not sure about that. 2 and 48. And now I can go to 6 and 8. And I can go to 2 and 3 and 2 and 4. Okay. Now once you come to this, it takes 2 of them to become under the radical to become 1. So for example, you can see that I have this, and then I break it down to this, and this. So it broke all the way down to there. Okay, radical 4 just becomes 2. Radical 2 times radical 2 is like saying radical 4. So these two just become 2. And same thing with these two. These radical 2 times radical 2, radical 4 becomes a 2. And now if you look what's on the left, I have 2 times 2 times 2, which is 8, radical 3. And so you can always break it down that way. Okay. So you can go down to prime factors if you want to, or until you come to a perfect square. If you want to come down to, if you came down to 2 and 96 and you knew this was 16 and 6, you could actually stop here because this becomes 4. And now you can break the radical 6 to 2 and 3. And so this one and this one would cancel out to a 2, and there's your 4 times 2, which is 8, radical 3. So there's different ways of breaking it down. All you got to do is make sure at the end you have a number that's not a perfect square under the radical. The way, if you want to check your answer, square this one. So 8 times 8 is 64, and then times 3, and you should get 192, and you should get this same answer here. So square this outside number, and then multiply it by the radical 3, and you should get the number inside the radical. Here's another one. You can go 6 and 3, but if I were you, I would try to get perfect squares in your first factors. So 6 and 3 are not perfect squares, but 9 and 2 is. So I know I can change this to a 3. So my answer is 3 times radical 2. A quick check. Square root of 3, 9. Times 2 is 18, and I was correct. If they give you something like this, it's saying 4 times radical 32. So what we need to do is leave the 4 on the outside, but now we need to break down the radical 32. And 4 and 8 are not perfect squares, but 16 and 2 are. So I can break this down to 4. And so now it's saying 4 times radical 2. So my answer would be 16 radical 2. Okay, that one, the check is kind of difficult because in this case there's only a number under the radical, whereas with this 4 on the outside, it's hard to do that check there. Okay, here's the removing variable factor. So what if I have variables under the radical? Okay, like I said over here, when it took 2 to come out, like so radical, or I don't know, radical 2 times radical 2 became a 2, because it's like saying radical 4, square root of 4 is 2. In the same way with variables, 2 of them underneath become 1 on the outside. Okay, so you can trade in 2 for underneath here to become 1 on the outside. So if I have 2 under there, that just equals to x. Both of them just come out. Okay. If I have 3 of them under here, that's like saying 1, 2, 3. Okay. These 2 can come out and become 1, and I'm left with 1 on the inside, so my answer would be x radical x. Okay. 2 on the inside, you can trade them in for 1 on the outside, and then you leave the 1 extra one underneath. Okay. In this one here, I have 5, so 1, 2, 3, 4, 5. 2 can become 1, 2 can become another one. So now I have x times radical x, because I have to leave that one underneath. And so this actually just becomes x squared radical x. Okay? So 2 on the inside can trade into 1 to the outside, but you got to have 2. If you have 1 left over, it has to stay underneath. Okay, so here's an example with 2 different ones. So basically I can divide by 2 if you notice. So if I divide by 2, I'm left with 1 remainder. So if I have x to the 4th, that becomes x squared on the outside. And if I have 3 y's on the inside, 2 of them can go to the outside, and I would be left with that. So the 4 would become 2 on the outside, and then 2 of these y's would become 1 on the outside, and the 1 left over stays in. Okay, if I have numbers like this, square root of 16, I know just becomes 4 on the outside. So it just becomes a 4. If I have 5, that means I can take 4 of them out to become 2. So these 4 can come on the outside, and now become x squared. And I'm left with 1x and 1y. Okay, so I would get 4x squared square root x y. Okay, again, the 16 just became a 4. I have 5 x's, so 4 of them can come out and become 2 on the outside, leave 1 on the inside. And I only have 1 y on the inside, so that would just stay on the inside. Okay, here's another one, multiplying radicals. So if I'm multiplying 2 radicals, I could combine these or simplify them down like how I broke down the 192 on the first example where you break it down. I could keep going that way. Or I can just see that this becomes, if I combine it, radical 100. And radical 100 just becomes 10. So sometimes instead of splitting them like over here, where you're breaking them down to factors, you can actually go backwards and make it easier for you. So in this case, I took the radical 20 and radical 5, I multiplied them together, becomes radical 100, and you get 10. Okay. In this case, I could combine it back again to 96, 8 times 12, and then break it down again, or I could just simply break it down some more and go radical 4 times radical 2, radical 4 times radical 3. Okay, I can see this just becomes a 2, a regular 2, and radical 4 is just a 2 again. These are prime numbers, so I cannot go down anymore. So it's 2 times 2, which is 4, radical 2 times radical 3 is just radical 6. I can combine them into one radical. Okay, and that's your radical 96. Again, if I square this, I get 16 times 6 is 96. So if I did go back to 96, I could do it that way. But again, you would just do an extra step anyway, so I would just start from the 8 and 12. Okay, over here I have another one. If I were you, it might be a little easier to combine so you can see them under one radical. So I'll go 5 radical 18c squared. I just combined the 3c and 6c. 18 becomes 9 and 2, and the c squared can just go by itself. So this becomes a, and don't forget the 5 out here, this becomes a 3. Radical c squared can become a c, and you're left with the radical 2. So when I multiply all these out, I get 5 times 3 times c, which is 50, and I leave the radical 2 underneath by itself. Here's another example. So I'm going to combine, I'm going to move. This is like saying multiplying this times this times this times this. So I actually can move this to the front and go 6 times 2 and make it a 12. Okay, I move the 6 over here, 12 times radical, and I'm going to combine this one with this one, and I get 50 a to the 5th. Okay, so I combine these two together. And now I need to break it down. So I leave the 12 here. I'm going to break this down to 25 to a to the 4th and a. And again, I want an even number so I can break it down. So this just becomes a nice 5. A to the 4th, if I divide by 2, becomes a squared. And I cannot do nothing with the radical 2 and the radical a. Those just stay. So now I can combine the 5 and the 12, and that becomes 60 a squared. And then I can put, now I can put this one and this one together and get a 2a. So again, look under the radical, no perfect squares, no fractions, and no radicals in the denominator, so that's my answer. Okay, now we'll go to the next one where we're doing fractions. And I will switch the light so there's no glare. If I have 40 divided by 10, the first thing you want to do is just simply simplify the fractions if possible. So 40 divided by 10 I know is 4, so it just becomes radical 4, and it just becomes 2. There, you don't have to do much with that. So look if you can simplify the radical first, or what's under the radical, the radicand, first, and then it makes life easier. If you cannot, so you got 11 and 49, what you do is you split it. So it becomes radical 11 over radical 49. So if you're multiplying or dividing, you can split them. So for example, over here, if it's multiplying, I can combine it, or I can split it by multiplying. Same thing with division in a fraction. I can leave them under one fraction, or I can split it into 2 separate fractions. Okay, and now I can see that radical 11 is a prime number, so that stays, and radical 49 is 7, and that's my answer. Okay, under the radical, there's no perfect squares. There's no fractions under the radical because only the 11 is under the radical, and the denominator does not have a radical, so I satisfy all 3 rules. Okay, you can simplify this fraction first, or you can split it and do it after. I'll do it both ways for you. So if you simplify, if I divide by 4, I would get radical 5 over radical 16. If I divide by 4, and that just becomes radical 5 over 4. Oh, I'm sorry, I should have done it this way. So I could simplify the fraction first. If you didn't, if you split it first, and you went radical 20 over radical 64. Radical 20 becomes radical 4 times radical 5 over 8. This becomes 2. So this becomes 2 radical 5 over 8. Now here's what I wanted to show you. If it's outside of the radical, I can simplify my 2 and my 8 because they're outside the radical. Inside the radical, you cannot. You can only simplify it if they're both under the radical. Okay, so if, for example, if you came out to radical 12 over 16, you cannot simplify the 12 and the 16 because the 12 is under the radical, but the 16 is not. Okay, so in this case, the 2 and 8 are both outside of the radical, so I can simplify it down to a 1 and a 4. So my answer is radical 5 over 4. Okay, here's another example with some variables now. So I'm going to split it to 16x cubed over 25y squared. This becomes radical 16 times radical x squared times radical x. I put an even number, and this just becomes 25, and then y squared. So this becomes a 4. This one becomes an x. This one stays as a radical x. This one becomes a 5, and this one becomes a y. Okay, so when I combine it, I get 4x radical x all over 5y. And that's my answer. Okay, the last part of this whole homework, rationalizing the denominator. Basically, if you have a radical in the denominator that's not a perfect square, it's irrational. So you want to make it rational or rationalize it. And the simple way of saying it is get rid of the radical in the denominator. Okay, in this examples here, I had perfect square denominators, so they came out nice and easy, so 7, 8, and all that. If I have something here where when I split it, it doesn't become a perfect square. So radical 5 is not a perfect square. Okay, that's not simplified. So what I need to do is multiply it by the radical 5 in the bottom. And the reason why is, now radical 5 times radical 5 is radical 25, or just 5. So radical times itself becomes a number without the radical. And 2 times 5 is radical 10. And there's my answer. Okay, so here's another example. If I have this, I want to multiply it by radical 8n. I want to multiply it by radical 8n. So on the top, I would get radical 56n. And on the bottom, radical 8n times radical 8n is just 8n. Okay, again, anything, if it's a radical times itself, it becomes that without the radical. But now I need to try and simplify 56. Does 56 break down at all? So this is where you go 2 and 28. So it would actually break down, because I can see 28 has a 4 in it. So I could go 4 times 16. No, that wouldn't work. I'm sorry. 28 and 2 is 56. So this is 4 and 7. So it'd be 4 and 14. So this would be radical 4 times radical 14 times radical n all over 8n. This becomes a 2. Okay. So you got 2 radical 14n all over 8n. But here's where I wanted to show you again. Be careful. The 2 and 8, make sure you simplify that to a 1 and a 4. So your answer would be radical 14n over 4n. And here's a big hint. Do not try to make sure this goes on the hint. Do not try to take this n out from the answer, because 1 is under the radical and 1 is not. Okay, so be careful with that. Just leave it as it is. You can only simplify it if it's outside the radical. Okay, here's another one. I'm going to multiply this one by 18t. 18t. So I get radical 90t over 18t. I can already see 90 is going to be 9 times 10. So I go 9 times 10, and I'm just going to leave the t under there because I know it's by itself. So this becomes a 3t. Oh, I'm sorry, a 3. And I leave the 18t. And so I got 3 radical 10t all over 18t. I'm going to cancel this to a 1 and a 6. And again, because this t is under the radical and this one is not, I cannot simplify those. So I'm going to leave it as radical 10t all over 6t. Okay. The other way to do it is I could have simplified when I split this to radical 5. When I did this radical 18, I could go 9 and then 2t this way. Sorry. And just change this to a 3. So when I go 5, I would have this over 3 radical 2t. And I could just multiply this by radical 2t over radical 2t instead of the whole 18t. I could just do the radical part. And then I would get radical 10t over 3 times 2t, which is 6t. This 2 becomes just 2t. Okay, if that confused you, then stick with the long way and multiply the whole thing. This is just a shortcut way of simplifying the denominator first to 3 times radical 2t. And that way you only multiply by radical 2t instead of by radical 18t. Okay, so that's section 11.1. I hope this helps.